Hey everyone, my name is Ash, and in today's Roblox Studio advanced scripting tutorial, I'll be showing you how to communicate between the client and the server efficiently. Now we're going to set up a full server-client communication system with only this folder here, with the event handler, event listener, asynchronous transmission, and the synchronous transmission. So no longer will you have to see thousands of events in a giant list or in a giant folder clogging up loads of space in your replicated storage. You only have this clean system here that you'll be able to use for all your events in Roblox Studio. Now before we actually get to programming it, I want to go through some of the theory behind the code, and I want to explain everything that's going on. It is a little bit complex to understand, but hopefully you get it. If you don't, leave comments. So the previous video's comment that I'll be reading out today is from Yes, and they said, great quality, keep going like this. I really appreciate all the comments and the feedback you leave on the videos. If you want to see your comment in the next video, make sure to leave a nice word down below. I read every comment. I try to respond to all of them. Any suggestions on tutorials that you want in this advanced series, please also leave them down below as well, and I will cover them. So before we start programming, we need to understand what we're actually doing here. Now, because this is the Roblox Advanced tutorial and not just a beginner tutorial for Roblox Studio, I want to go over some of the detailed theory behind asynchronous and synchronous transmission. Now, the system we're about to lay out relies on two things, and those are being asynchronous and synchronous transmission in Roblox Studio. Now, the definition of asynchronous and synchronous differ, where synchronous means you're completing one action at a time. So in this example, let's say I have our server here and we have our different clients. Synchronous transmission will allow you to communicate with a client one at a time. On the other hand, asynchronous transmission in Roblox Studio is basically just where you can call an event on multiple clients. So for example, here we have our clients and our server, and the server calls a function for all clients, and all clients will receive that call, and that is asynchronous. They're happening at the same time. Now in Roblox Studio, the way we can produce synchronous and asynchronous transmission is through our remote events and remote functions that are built into Roblox Studio. Now, if you've guessed by now, remote functions are really useful for synchronous transmission, and remote events are really useful for asynchronous. Remote events have this function called fire all, and you're allowed to fire every client, which kind of produces that asynchronous transmission. Now, how do we go from producing this theory and putting it into Roblox Studio? And how do we get only these items for a whole video game? Because I know a lot of video games have many events stacked on top of each other, and they look messy, and you can have loads of different events for the same thing almost. Well, the structure of the code we're going to make today includes an event handler, an event listener, the remote event, and the remote function. To keep things organized, you want to keep everything in folders. It just helps you structure your work, and when you're programming larger games, it becomes really useful to keep everything in a folder. So in this program, we're going to have two folders, events and utility. Utility is used for our functional programming, which we learned in episode 1, and events are going to store the 4 items that will be used to create the system. Now, what is the aim of doing this? Well, in our demo, we're going to create a UI element, and it's going to change based on what we call as an event when the client joins the game. So for example here, if I click play in the final demo, as you can see, the text changed to the binary representation in ASCII of my username. Now, the useful thing about this is that I can change the function by changing a simple string in the code. In the server, if I change this string to change UI name like this, we now have only our name represented up here in the UI instead of the ASCII representation. And this was all done through these 4 items here. So this is a very powerful tool when creating events. This is also fairly okay against hackers, because a lot of hackers use remote events to spam your game and lag it and crash the game. They'll basically call an event over and over again until your game crashes. So what you can do is add a debounce to each of these, and you don't have to worry about them calling any other event, because you can make sure these 2 are protected against hackers. So let's start out from scratch in Roblox Studio, so I can show you how to create efficient client-server communication in Roblox Studio. So starting out from scratch, the demo we're going to make includes a UI element, and this is going to change based on when the user joins the game. So in our starter GUI element, we're going to create a screen GUI to act as the player's screen. You're going to want to name it player screen, and then in that player screen, you're going to want a frame, and it should appear on the left-hand side. We're just going to leave it as frame for now. Now, in your properties here, we're going to want to center it and make it the size of the screen. So the way you center it is by changing the anchor point to 0.5.5. We're also going to change the size to 1010, and it should look like this now. And now we can change our position to 0.5.5. It should just create a blinding white screen. Obviously, we don't want the blinding white screen, so we can set the transparency to 1, and that will remove it from our screen. Now, inside the frame, we're going to want a text label, and you can name this whatever you want. I'm going to name it label. We also want to center the label and put it kind of up here so we can see the name when we join. So to do that, again, set the anchor point to 0.5.5. I would do this every time with UI. Change the border size pixel to 0. Change the background transparency to 1 to get rid of that horrible white box. 0.1 on the Y so we can see it kind of up here. The size we want to set to maybe 1.1 1. And if we scroll down to the text properties, set the text to name, and we want to scale the text so we can see it here. You can basically customize this however you want. Now I'm just going to give it a font. There we go. So the name is up here. It's pretty large. It's just for a demo purpose, so we can show the events working when we create the script. If you don't want to do this, you want to set up just the event system, then obviously skip to the event system. It'll be in the chapters in below. We'll be working in the replicated storage. We'll also be working in server script service to hold the server script. And finally, we will also be working in the starter player scripts for the client. So in starter player scripts, we want to create a local script and we want to call this the client. In server script service, we want to create a normal white script. And in replicated storage, we want to create 2 folders that we mentioned earlier. And these folders are going to be called events and utility. The events folder is going to hold the asynchronous and synchronous events. And the utility is going to hold our for loops module that we've been using in the previous tutorials. If you don't know what the for loops module is, I recommend going and watching episode 1 and then come back and continue with this one. So in our events folder, we need to create 2 events, our remote event and our remote function. So our remote function is going to be our synchronous transmission. I'm just going to call it synchronous, and our remote event is going to be our asynchronous. We've now got our asynchronous and synchronous transmission set up. Now also in our event, if you remember before, we need to create 2 module scripts. So the remote listener will listen out for any requests that are given by the server or the client. In our model, the server will have a listener and each client will also have a listener. This just allows us to communicate between the client and the server and go back and forth between the two. Now the event handler, basically when we create an event handler, we are creating the class that allows you to call events from the server or from the client, depending on where you create the event handler. So let's say we have our server here. We want to call an event onto a client and communicate with that client. And this works the other way around. If the event handler is created in the client, you'll be able to call an event and call the event to the server where the server will receive that communication. So for summary, just think event handler is for calling events and the event listener is for receiving events. So now your project should look like this. We have our events and our utility. Our utility is empty for now, but we will add that later. So the first thing we want to start off with is in the server. And when do we want to change this name? Well, we want to change this name when the player joins. So in our server script, if you open it, we put it in server script service. We are going to need some services. We're also going to need some functions. We're also definitely going to need some variables. We're also definitely going to need an event. So what services are we going to need? Well, we're going to need the player service because player service allows us to call the on-joined event when a player joins the game. So we've now got the player service. We're also going to need to try and reference these 2 scripts here, the event handler and the event listener. So we're going to need the replicated storage as well. We've got our replicated storage and our player service. In our events, we want to set up our player joined event. Well, we use our player service. We use the .player added event. And this event here is going to allow us to detect when a player joins. We can run an event that changes the UI element on the screen. Now remember, you can do whatever you want here. This is just an example of how to use the system we're creating. You can use the system for any remote event possible. This is just a short, simple example. Now for variables, we are going to need a reference to our event handler and event listener. We're also going to need 2 other variables. So let's get a reference to our event handler and event listener. This is our event handler reference, and this is our event listener reference. We will be adding more to these lines later on in the video, but we haven't created our event handler and event listener yet. Now the final 2 variables we need are 2 tables, and these 2 tables are asynchronous functions and synchronous functions tables. Now for the server and the client, they both need asynchronous and synchronous functions. What these are going to be used for is we're going to store different functions that we want to carry out in our events. So for example, if we want to change the name, if we want to move the player, start the round of a game, we can put these into our functions table, and when a client calls the server, these functions will be run. So if a player requests to move using a remote event, it will call the move player function in the table, hence moving the player on the server. Now what I actually want to change here is I want to put these above these because the event listener will use these variables, so I need to put it above, not below. So that is all for the server for now. Let's move on to the next script. So what you can do for the client script is you can actually copy and paste all of this from the server, go down to our client script, and you can actually paste it in here. We do have one thing we need to change. We need to change the player service to the GUI service. So if we change this player service to GUI and change players to starter GUI, now everything's set up in the client script as well, ready for us to create our event handlers. So we are going to start with the handler, the event handler, and the event handler is going to be a class. If you don't know about object-oriented programming in Roblox Studio, then I would recommend to check out my first Roblox Advanced scripting tutorial. You can rename this whatever you want. I'm just going to call it event handler class. Now what you're going to want to do in the event handler is actually get a reference to the replicated storage service. So with this line here, we get reference to the replicated storage, and we're actually going to reference the for loop module in the event handler. So I'm going to create it in the utility now. So just create a new module script in the utility, call it for loops. We will set up our functional programming programming later. So now just get a reference to the module. And remember, we want to require the module because we want to access all of the functions inside the for loops module. So with our event class, if you remember from last video how we set up a class, we need to use the .__index and set it to itself. This is useful for inheritance, but we're not doing any inheritance today. Now we need to create our constructor. And if you remember from the last video, our constructor is just what creates the event handler. So this is how we create our constructor function. We use the event handler class because we want it in this event handler class table, and we use .new. And we also want to pass in a name because we want to give the event a name, just so we can identify different event handlers for different scripts. So the server event handler will have a name of server event handler, and the client one will have client event handler as its name. Remember, we need to create our self variable, and we want to set the meta table of that to nothing, an empty table with the event handler class as the second parameter. If you don't remember doing this, or you haven't experienced object-oriented programming, please do go back to the previous tutorial. I don't know why you'd watch episode 3 without episode 1 and 2. So what do we want to do in this constructor? Well, we want to return the self, but we also want to create two variables within our constructor for our instance of our class, and that will be the self.asynchronous bridge. Now I'm calling it the asynchronous bridge because it's the bridge between the server and the client. You have to cross this asynchronous bridge before you can communicate with the client or the server. And I'm doing the same with synchronous bridge, and these both reference the two events that are inside our replicated storage that we created earlier. We also want to create a new variable called self.name, and we want to set that to the name that we pass in as our parameter. Okay, so our constructor is set up. We're almost ready to start sending out data to the client or to the server. Now remember, the client and the server will both have access to the event handler. They'll both use the same event handler. So what data do we actually want to send? We want asynchronous types and we want synchronous types. So for each function we create in our class, we want to create a function for each type of data we want to send. Now on the screen you can see the different types of communication we're going to add to our event handler. We want to send data asynchronously to a number of clients, and that means that you're sending out an event from the server to a certain amount of number of clients. That could be one client, it could be 5 clients, but we want that to be a function. So that will be our asynchronous clients. Another one we can do is sending out to all clients. So if we have our server and we send it out to every single client will receive that event. And remember, we're using asynchronous for multi-client transmission because asynchronous allowed for multiple at once. Now another one from server to client will be the synchronous function. And remember, the synchronous is one at a time. And remember, the synchronous relates to the remote function, which allows for one-to-one transmission. And it's also two-way. And what I mean by that is that when you send something, you'll receive something back. So we have synchronous client, which allows you to communicate with a client. Now these are our client functions, but what about the server? A client can't fire all servers, so there's not going to be a synchronous all servers, but there will be an asynchronous and synchronous server function. The first one, synchronous server, is going to allow us to use our remote function to have two-way communication between a client and the server, and the asynchronous server will allow one-way communication between the client and the server. So now we need to fill in all these functions, and we're going to start from the top one. If you think you can fill these in by yourself, give it a go. If you can't, just watch the video because all the names can be quite difficult to understand. So for asynchronous client, we want to call a certain number of clients. How do we know which clients we want to call? Well, we take in a parameter called clients, and clients is going to be a table which holds a client and the function that you want to call on the other side. Now, what's really useful about this is that you can put in multiple clients with different functions. So let's say you have 2 clients that are losers and then you have one that's a winner. You can call the winner function for one client and the loser function for the other client, all at the same time. So to help us understand what we're doing here, we're going to add some print statements. Okay, so I've added some print statements to describe what each one does. So let's fill in the rest. Now, in terms of parameters for asynchronous all clients, which goes from server to all clients, we just want to pass in the function name that we want to call on all clients. So this function name could be announce winner on screen, and that function will call for all clients. We actually want the function name for all different transmissions that we're doing. However, when it comes to the synchronous client, we want to pass in the client as well, because we're going from server to a specific client, which will be our client, and then back to the server. So we need a specific client there as well. So we need to reference that client. We're going to leave asynchronous client to last because it does rely on us using our for loops module. We're going to start with asynchronous all client. We're going to reference our asynchronous bridge from our constructor, and we're going to fire all client. Now what I'm going to do is I'm going to send the self.name of the event, and I'm going to send the function name as well. Now this isn't actually set up yet because we haven't set up our listener, but when we set up our listener, you'll see that these become very useful for us. So just put them in here for now. In our synchronous client, what does the synchronous client do? Well, it goes from server to client to server. So it's going to be invoke. So we're going to use self.synchronous. We want to invoke the client because we're going to the client, and we want to pass in the client that we passed in as our parameter here. here, and we also want to pass in the func name. This will now allow us to go from the server to the client to the server again. Now for our synchronous server transmission, we want to go from the client to the server to the client. So this is also going to be a synchronous transmission. So we need our synchronous bridge. We want to invoke the server this time. And when we invoke the server, we want to send in the function name. And that's all we need to send in because we're going to the server. For asynchronous server, we want to run a remote event because we're using asynchronous transmission here, which is one way, and we want it to be one way. Technically, you could class this as synchronous because we're not going to multiple servers. There's no way we can, but this is just our one-way transmission. It's easier just to name it that. So for our asynchronous bridge, we want to fire the server, and the fire server, what this does is it allows you to go from client to server. Once we've fired up the server, we want to send in our func name. So now we want to set up the asynchronous client, but we need our for loop module for that. So how the asynchronous client is going to work is we'll have our table of client with their respective functions that we want to call. We're going to loop through each one, and we're going to call our synchronous client transmission. So for each client, we're going to do a synchronous client transmission from the server to that single client and then back to the server. In our for loops module, we want to just get rid of everything and only return a table. And in this table, we're going to have, so I'm calling it for loop for class methods because when you do a normal for loop with functional programming, the method that we're passing into the function isn't part of a class. However, this time it is, and it does change up the parameters a little bit. Just because of that self connection, it kind of loses it through the function. We're going to pass our function and our data, and this function is going to be our asynchronous transmission that allows us to transmit from server to client and then back to the server. To make this easier, let's go back to our event handler and let's actually use our for loops variable to call this to show you what is being passed into these two parameters here. So when we call it, we want to do for loop dot and then our for loop class method, and then we want to pass in self.synchronous client, and our self.synchronous client is going to be our function. Self.synchronous client, remember, goes from server to client to server, and it takes in a client and a function name. So this second parameter here in the for loop class method is going to be the client's table, and that's because we're passing in the client's table and then we're running our for loop on this table and calling the function based on a client and its function. As you can see by the screen, because our client's table matches up with the parameters of synchronous client, because we've got our client as the key and then the function name is the value, we can call this function using functional programming. It just reduces the amount of code we have to write. So in our for loop module, we're going to create a for loop inside of this function, and it's going to be for client func name in pairs and then the client's table that we passed in here. This is how we split up in a for loop. We've got our client as the key and the function name is the value, and then we can literally just run a function. Now this is where it gets weird in terms of, this is why we separated for loops for class methods and maybe a normal for loop would be underneath. We actually need to pass in nil first and then the client and then the func name, and this is because we don't have a reference to the self where the function is coming from. Because we're calling it from inside a class, you need to put nil here. However, this is a solution to get around this. If you do know another solution to this, please be my guest and put it in the comments. It would be nice to know. In our asynchronous clients method in the event handler, we want to call our for loops module, and then we want to call our for loops class method that's inside this table, and this will basically run the function, and we have our function here which is our synchronous client, and then the final bit will be our client's table, and this now will basically run for every client. It will run a synchronous client transmission. One final thing we should do in the event handler class is when you have self.asynchronous bridge, just change it back to rs.events.asynchronous, and every time you have synchronous, change it to rs.events.synchronous here. So just do what I'm doing, just replace each one. So synchronous here, replace that. This will avoid any issues that you have with this for loop class module. It's just the way that object-oriented programming is set up with functional programming. So this is actually it for the event handler. We're going to move on to the event listener now. A long time ago in the video, we created these two variables in the server and client, asynchronous functions and synchronous functions. Now these are going to be useful in our event listener because different event listeners will be able to have different functions, which allows you to distinguish different events from each other. If we head into the event listener now, and you can rename this whatever you like, I'm just going to call it listener. Now the services we're going to use in the event listener include the replicated storage service. We're also going to use the player GUI service. So these are the two services we're going to use. Replicated storage is defined like this, and the GUI service is defined like this, same as the client. And this is also going to be a class, so we need to create our constructor. So this is our constructor here, our listener.new, and if you remember, this is how we create our constructor. And all we're going to need for this class is a constructor. Actually, we're not going to need any functions functions underneath. Now we are going to need some parameters for this listener, and the parameters we're going to use are the functions we create in the client and server, so our asynchronous function. And we also want a trace, so every time we create a listener, we'll be able to trace what script created the listener. This is useful for debugging. You don't actually have to use a trace. Obviously, with any class constructor we create ourselves, you should be getting used to this by now. Now I created a little print statement within the constructor to say where it came from, just so we can see it in the demo. Now the two variables we want to create in the constructor are obviously our synchronous functions and our asynchronous functions. Now these two are important so that we have individual functions and methods for different events. So as you can see on the screen, one event might control the shop and that can have its own functions, but one event might control the round and that will have a different function such as load map. Now what we want to do is check if the event listener is running on the client or the server. If the listener is running on the client, we need to run two on-client event or /invoke that come from the remote event and remote functions. However, if it's on the server, we need to run the on-server event and the on-server invoke. Now, one of the ways you can check whether a script is on a server is by using a pcall function, and we used this with our data stores in the previous video. And this is how we define our pcall here. Remember, a pcall is like a try, catch, exception. It will try and run the first code. If it can't, if there's an error in that code, then it will skip. It won't throw an error in your program. At the end, we also want to check if not a success, because we're going to purposely throw an error if the user isn't on a client, and then we'll run the server events in here. So what we can do now is run our event for the client in here. So we have our two clients here which relate to our asynchronous and synchronous transmission that are in our events folder in our replicated storage. So what this basically does, it will connect the client to the event asynchronous and synchronous, and these will run every time it is called. Now that is one of the downsides to this. If you connect a bunch of different clients with a bunch of different event listeners, you're going to be calling all of the event listeners at the same time. So for our asynchronous client transmission, what do we receive? Well, in here you can see we are sending off our self.name and our function name from our asynchronous bridge. So in our event listener, we need to have a trace and the function name. Now in our synchronous transmission, all we put through is our function name. The client is just so we can specify which client we're going to. So all we need here is our function name. So I've added a little print statement in the asynchronous event. So what do we want to do when asynchronous is called? Well, we want to check our asynchronous function, see if the function name exists. If it does exist in the table, we're going to fire that function because that's what the user wanted to do in the first place. So to check, we need to use an if statement. We need to check asynchronous function, and we need to check if func name exists. So if self.asynchronous function's func name, if that table has a place for the function name, the return value of self.asynchronous function func name with the function called. So this basically just runs the function that's inside the table, and you'll see the table a bit later to see what it looks like. Now we can copy and paste this basically into our synchronous, but we do need to change it to our synchronous table. So change anything that says asynchronous to synchronous functions. We also need to make sure that it returns something, because event.synchronous, remember, always returns something back to the client or server. In this case, it's the server because of on-client invoke. So on the end of this, we could do else return nil, and this else return nil will make sure that something is returned regardless of the outcome of this if statement. So this is it for the client. What we can actually do now is just copy and paste it. So if not success, then basically we are on the server. We want to do an on server event instead. So change all of these client events to on server event. On client invoke will be on server invoke now. Now we need to double check with asynchronous on the server in the event handler. So our asynchronous, we're sending in the function name, but we're sending it from the client. So we're going to have the player coming through, not trace, and we've also got the function name coming through, and this is the same for both of them. So we can have player function name. These parameters are the same for both of these now in the if not success. One final change we need to make in the event listener is we need to add the player reference so that we can reference the player in our function when we call the events. And that is basically it for the event listener. So in the server, we're going to create a template for a function. We're going to call it move player. We want to move the player to a position, and we're going to call it function, and we're going to pass in the player as well. We're going to want to pass in the player here because we're going to need the reference to the player to move their character. Now in the client, we can also create some functions. Now we're going to create some synchronous functions to kind of change up what we're doing. Now remember, synchronous, we have to return something. When we use synchronous functions, we're using a remote event. So in our synchronous functions of our client, we can create one change name on UI, because remember the initial goal was to change the name of this UI here. So we want to change the name of the UI. So we create our function change name on UI. If it works, we're just going to return true. So if we go back to the server now we have our event handler and event listener set up, we can actually change these variables here. Remember, we set them at the start of the video. We need to change them to reference the class because we did create constructors here. So we need to put .new. Now for our .new, for our event handler, we need to have a name. For our event listener, we need to have our asynchronous function. We need to have our synchronous functions, and we also need a trace. So we're going to do script.name. So when the player is added, let's finally add some functionality to this. Let's create a print statement saying the player was added. When the player gets added to the game, check if the player character is loaded. So we can repeat wait or task.wait. Let's do task.wait. Repeat task.wait until player.character is not equal to nil. So I want to show you how to use the clients table when we push in asynchronous client. So if I have a clients table, let's just create one here when I join the game. You basically do it like this. So I've got the reference to the player here. This isn't the player character, this is the player, and we're going to equals that to the function name that I want to call. And if we go back to the client, I want to call change name on UI. So I want to call that function. Now we've got our clients table, we can basically go into our event handler and call our asynchronous clients function. So let's get our event handler. We use the colon to make sure that we pass in the self, and we want to call our asynchronous client because we want to call multiple clients at the same time. So asynchronous clients is this one. We pass in our clients, and as a result, if there aren't any bugs, as you can see, the name has changed to the username of the player. If you look in the output here, the event was created from the server. The player was added to the game on the server as well. The event created from client. We call the asynchronous transmission. So from server to clients, we had multiple clients. We only had one client, so this only got called once. And this was our synchronous transmission, which went from server to the single client to the server. And this called our function, and it changed the name on screen. Now you can do the same with the client as well. Obviously with the client, you can just call the event handler. We can just run a asynchronous and send it to the server, and we want to move the local player. I think we called it move player. So if we wait here now, we've got the reverse string, and we're going to get teleported. As you can see, we got teleported to 2020. That is how you do from client to server as well. Obviously there are expansions to this. Obviously there are like certain things like arguments that we'd want to put in. However, that is all I've got to show for you today. This was episode 3 of my advanced Roblox Studio scripting tutorial. In the next Roblox Studio scripting tutorial, we're going to begin on data structures and algorithms to make sure that your code is the most efficient as possible. We're going to give examples on how different data structures can be effective and also introduce you to time complexity. But anyways, hope you learned something. If you have any questions, let me know in the comment. If you haven't watched my devlog, I've started a devlog where I create a pirate game similar to Sea of Thieves. So if you haven't seen that, it'll be on the screen now, and I'll see you in the next video. Thanks for watching.